Hello, welcome to the lecture. So now in this lecture, we are going to learn a new aspect of the force, which is the moment. So these are the content that we are going to discuss in this lecture. So now talking about the resultant. In the previous lecture, we have calculated resultant of the coplanar concurrent forces. And we know concurrent forces are those forces which may originate or which may act on a point simultaneously. Now, when we have non-concurrent forces, they will be coplanar, but when we will be having non-coplanar, I mean non-concurrent forces, how do we find out resultant in that case? Well, in case of non-concurrent forces, the another aspect of the force comes into the play, which is called the moment. So we will now understand more about it. So as I said, in the analysis of concurrent force system, it is sufficient to consider only the basic force vector. So in case of the concurrent force system, like we have done in the previous lecture, we were only considering the magnitude of the force, we were considering only the direction of the force and the sense of the force only. And with that, the equilibrium condition was established. But now that is the case of the concurrent forces. But what if we have non-concurrent forces? Then how do we find out the resultant and which aspect of the force comes into the play, that we will see. So first we will see this with a figure. So this figure is of two forces which are acting on a single point. So these two forces are the example of concurrent forces. They are acting on a single point. Now they are acting on this line. This line may be any horizontal body. Now the equilibrium in this case sets because both the line of action of both forces are in the same line and they are acting on the same point. So their magnitude is the same, but their sense is opposite. So the resultant of this system will be zero. And resultant will also be acting in the same line, same vertical line. So you can see only one equation is sufficient to establish the equilibrium. There will be no movement in this system. But now, as I said, in case of non-concurrent system, what happens? In case of non-concurrent system, then there is another effect of force comes into the play, which is called the moment or the rotational effect. Well, force is also having a rotational effect. This rotational effect will comes into the play when the force are not concurrent. So now I will show you the second photo, and in the second photo you can see the same forces, they are having the same magnitude, they are having the same sense, but the difference is they are not concurrent. They are not acting on a single point. Now in the non-concurrent system, they are acting on two different points and they have a distance a. So in this case, this equation is not sufficient to establish the equilibrium. Why? Because you can see according to this equation, it says that algebraic sum of all the vertical forces should be zero. So yes, this force is downward force. So downward force we take as negative 10, and this force is upward force. So we take upward force as positive. So plus 10. So it gives us the zero value. But this system is not in the equilibrium, while this system is in equilibrium because there will be no movement. But now in the second case, there will be a movement in terms of the rotation. These two forces will try to rotate this body like this. So there is another effect of force comes into the play, which is the rotational effect. And this rotational effect is known as the moment. So now we will understand more about the moment. What is it? So when a force is applied to a body, it will produce a tendency for the body to rotate. about a point that is not on the line of action of the force. We will more understand this with the photo. So in this case, you can see there is a spanner and we are trying to rotate this bolt using the spanner. So what we are doing is we are applying the force on this spanner, which is at a distance from the point O about which this spanner will rotate. So we are applying F force, and we are applying this F force at d distance from the point O. So you can see this spanner will rotate about point O. So this is the general representation of the moment. So in moment, we will always apply force at a distance from the point about which the body will be rotating. So this time the body is the spanner, and we are applying force on the spanner at a particular distance from the point O so that it can move about that point. And this tendency of rotation because of the force, well, in the physics, we understand this term as torque, but as we are going to learn the basics of the mechanics, so in the mechanics most often it is used, the term used as moment. So we will be talking about the moment. Now in the moment, there is one another aspect that we need to consider, that what is the angle of the force which will be making from the line, the distance is d. So this distance d will be only when the angle of the force will be 90 degree. So like it is showing the angle theta. So now you can see this d dash, if we apply force at any other angle, if we apply force at any angle, in that case the distance between this point and this point is obviously d, but the line of action of the force, may have distance other than d, and that distance will be known as d sine theta. So now to have the maximum effect of the moment, what should be the angle? So when we put 90 degree in place of the theta, then sine 90 will become 1, and in that case the distance will become d. So as I said, the maximum effect of the force will be when the value of, the distance between the force and the point O will be d. So if we apply force at any angle other than 90 degree, then maximum effect of the force will not occur. Maximum effect of the moment will not occur. It will occur only at the 90 degree. Okay. So that is why we always consider that force will be acting perpendicular to the distance. So distance there is d. So this force will always be acting at 90 degree to get the maximum effect of the moment. Similarly, if we apply force at any other angle, say 0 degree or 180 degree, so you can see at 180 degree force will be parallel to the spanner. So in that case, if we try to apply force, then rotation of this spanner will not occur. It will simply try to pull it. So, or in other words, we can say that the line of action of the force will be in the line of point O, or it will become concurrent force. So in that case, there will be no rotation. So now we can say that concurrent forces generally will not have this effect of rotation. This effect of rotation will be in case of the non-concurrent forces. So now we will try to know more about the moment of force. So moment of force is a vector quantity because it is having a specified magnitude and it is having a proper direction. We can understand this with this figure. You can see this is the force, and the force is rotating about point O, and you can see there is a vertical axis point about O. So in this case, the force is rotating about this axis, which is perpendicular to the plane of the force, I mean a plane in which the force and distance is existing. So this is the perpendicular axis about the plane, or in two-dimensional form we can see force is having a distance from point O, then only the rotation is occurring. And sometimes what we do is we represent this rotation by this curved arrow. And as the moment is about O, so we represent moment as M, and in the subscript it is O. So what would be the magnitude of the force? Well, magnitude of the force, magnitude of the moment will be the force multiplied by the perpendicular distance. So magnitude of the force multiplied by the perpendicular distance, that is the magnitude of the moment about point O. Well, this d distance sometimes called the moment arm, and this will always be perpendicular distance. We will always consider this as the perpendicular distance from the point O. And the unit of moment in this case would be the product of unit of force and unit of distance. So unit of force is it may be Newton, kilonewton. Okay. Similarly, the unit of distance can be centimeter, mm, or meter. So ultimately, the unit of moment will become Newton meter, like this, or Newton mm, or Newton centimeter, or kilonewton meter, kilonewton mm. So we can have a lot of combination depending on the case. So now we have talked about the magnitude. Now we will talk about the direction. Well, direction of the moment can be, now in the current case, in the photo you can see the rotation is occurring like this. So this is anti-clockwise rotation. Similarly, force can have clockwise rotation. So direction is actually sensed from the rotation. So moment direction can be clockwise or anti-clockwise. Okay. And this direction is also defined by the moment axis, about which axis the moment is happening. So for example, in this case, you can see in the 3-dimension, force and distance, they are in a plane, and the moment, the rotation is occurring about an axis which is not in that plane, or which is perpendicular to that plane. This moment can also be recognized by the right hand thumb rule. So if we look at our palm, if we look at our finger, and if we close our palm, then our finger will be curling. So that curling is also a sense of rotation, and it is actually the anti-clockwise rotation. So that is what it is trying to depict. Now, talking about the next concept, which is again related to the moment of force. So we are discussing this about, we have started this discussion on the fact that how do we find out resultant when there are non-concurrent forces. Well, in case of non-concurrent forces, we are supposed to find out resultant of moments also. We are supposed to consider the effect of rotation also. So if there are n number of forces acting on simultaneously on different points, so how do we find out the effect of moment of all the forces, and in terms of a single moment? So how do we do that? We can see in this figure there are 3 forces acting in a different direction. So the line of action of F2 force is like this, and line of action of F1 force is like this, and line of action of F3 force is this. So the moment created by 3 forces are named as M1, M2, and M3. So they have different rotation, they have different magnitude. So if we want to replace the effect of this rotation with a single force moment. So how do we do that? For that, we need to understand uh, the direction. Like we need to understand the sign convention. So if there is a clockwise moment, we will consider that as a positive. If there is a negative, or if there is an anti-clockwise moment, then we will consider that as a negative moment. So there also I have written, in the sign convention, we will consider positive moments as the clockwise moment, and counterclockwise moment will be considered as the negative moment. So the moment, so now if we want to find out the resultant moment, so the resultant moment, I mean the resultant moment representation is like this. So M is the moment, R is the resultant, and O is the about the point about which we are going to find out the moment. So in this case, resultant moment will be the algebraic sum. It will be the algebraic sum of all the moment of forces. So it would be equals to first moment due to force 1. So it is creating anti-clockwise. So we will put the negative sign. Similarly, the moment due to force 2, which is M2, and you can see M2 is the clockwise. So we will consider this as plus. Similarly, the moment created by force 3, so it is M3. So we are taking this as M3. And M1 is minus F1 into D1. So M1 is the product of force F1 and the moment arm D1. Similarly, plus M2 is the product of F2 and D2. Sorry. Similarly, there is M3. So M3 is the product of force F3 and D3 perpendicular arm. So once we find out this algebraic sum, we can find out the resultant moment. So that is what I have done also here. You can see. So this is how we find out the resultant moment when there are n number of forces acting on the body. So in the next part, we will take some example to understand this moment concept with more clarity. Thank you.